Right. Now that we are done, wonderful people, with our question 3, let's try to go to question 4 and see how differential calculus is compiled for N4 students and what is it that they should be aware of. Alright, in question 4 they say determine the following limits. So the limit as x approaches 4 of root x minus 2 divided by x minus 4. Now the first thing I should look at is that whenever you are dealing with the limits, your denominator should never and ever be equals to 0. When you take 4 and you plug it here, it makes the denominator be 0, so you can't do that. Now, how are we going to solve this now? Somebody might try to rationalize the denominator and see where that would lead you. So somebody might say the limit as x approaches 4 of root x minus 2, x minus 4, x plus 4, x plus 4. We are rationalizing the denominator. And then somebody might say the limit as x approaches 4 root x minus 2, x plus 4, x minus 4, x plus 4. The limit as x approaches 4, we can multiply there and we will find x root x plus 4 root x minus 2x minus 8 divided, we can multiply x squared plus 4x minus 4x minus 16. This is what we can have, and we can have the limit as x approaches 4. So what is it that is going on here? We have x root x, and I know that this is x times x to 1/2, and when I multiply numbers of the same basis, I add the exponents. 1 plus 1/2, it's 3.5. So I can have my x 3.5. I have 4 root x minus 2x minus 8. There's nothing that I can change in that. So I would still have 4 root x minus 2x minus 8. This into this goes, they are like terms, positive and negative, they would cancel. And you have your x squared minus 16. You're still having a problem with this, because when you plug in 4 there, this is going to cancel. Now, how do we do this? That should be the second question. Somebody looked at this in this manner and you saw that it never works, and then the question is, how are you going to do this? How are you going to do that? Okay, so even if you can try to rewrite this is 3.5 plus 4x, this is 1.5 minus 2 minus 8 all over x squared minus 16. I don't think you can factorize this. I don't think there's a way that you can factorize this in such a way that some of the terms might cancel one another. I don't think that could be a possibility. I don't think that could be. But another approach, the limit as x approaches 4 of root x minus 2, x minus 4. I can look at root x and rewrite this as the limit as x approaches 4, x 1/2 minus 2, x minus 4. Look exactly what I'm going to do here. The limit x approaches 4. I have my x 1/2 minus 2. I can write this as x 1/2 times x 1/2 minus 4. Because when I multiply, I add the exponents. Can you see that? And now I might have something. The denominator looks like a difference of 2 squares. The limit as x approaches 4 of x 1/2 minus 2. This can be rewritten in the following way. X minus 2x plus 2. And what is this? This is 1/2. This is 1/2. Because I can say let x 1/2 be equals to k. Let me just do it in that way so that you may see exactly what I'm doing here. By letting x to exponent 1/2 be equals to k, I can have k minus 2 and I can have my k squared minus 4. Can you see what I'm trying to do here? And I can say the limit as x approaches 4, k minus 2, this is a difference of 2 squares. Now this into this goes once. You have the limit as x approaches 4 of 1 over k plus 2. I think that is clearly visible. And then when I'm here, I can now let x, I can rewrite this as the limit as x approaches 4. My k is x to power 1/2 plus 2. Now I can substitute 4 here. I can have the limit as x approaches 4 of 1 over 4 to exponent 1/2. That is the same as the square root of 4, which is 2 plus 2, which is 4. So the limit as x approaches 4 becomes 1 1/4. Something worthy of noting. Something highly worthy of noting. Right. So that was question 4.1, something a little bit that required that you think a little bit outside of the box, looking at what you have on the numerator and trying to work on your denominator. That's fine for 4.1. We can try and look at your 4.2. In your 4.2, determine with respect to x, y equals 10x. Y equals 10x divided by the ln of x. With the aid of a quotient rule. We must use the quotient rule. Right. Determine with respect to x, y equals 10x divided by ln of x with the aid of the quotient rule. So they are very specific that we should use none other than the quotient rule. I know that the quotient rule, y prime, because we are differentiating, I hold on the denominator, ln x. I differentiate the numerator. I know that the derivative of tan is x squared. X, and then the quotient rule tells me to minus. That's exactly what you should do, because I think you have these things on your formula sheet. They provide them. And then I hold on this, I differentiate that, minus I hold on 10, and I differentiate ln x, that will be 1 over x. The derivative of ln is 1 over x. Divide by the denominator squared. That's exactly what you will have. So, can I go any further with this? I don't think so. I can just say sec squared x ln x minus 10x times 1 over x divided by ln squared x. I don't think there's any other thing that we should do there. We have already used that. We have already used that. We will have our sec squared ln x minus tan x times 1 over x divided by ln squared x. I think that's exactly what we should have. And then in 4.3, they say differentiate with respect to x. What are we differentiating? We are differentiating y equals ln x squared ln squared x with the aid of the product rule, and 5 mark is provided for this. We must differentiate this, and what I'm going to show you here, it's very, very important that we note the following, that here x is squared, but in here ln of x is squared. So let's rewrite this. It's the ln of x squared. This is ln x that is squared. So that's the difference between the two. So y prime, remember they said with the aid of a product rule. I know that the product rule would say to me, hold on this, ln of x squared, and differentiate this. I will bring down the 2, hold the angle, which is ln x, and differentiate the inside angle. The derivative of ln x is 1 over x, plus, I will hold on this time ln x squared, and differentiate ln of x squared. Now, how do I differentiate ln of x squared? That's the question. Now, I know that the derivative of ln x is 1 over x. So the derivative of ln x squared, that would be 1 over x. I hold on the angle, or we can say, let's try to look at this. We can say, okay, I know that the angle in this case, let's do this. The angle in ln x, the angle is x. So what we did here was that we say 1, the derivative of ln x is 1 over, we hold an angle, and then we differentiate the angle. The derivative of x is 1. That's why it doesn't make any difference. Okay? But in here, the angle is x squared. So the derivative, you will say 1 over, you hold the angle, there it is, and then you differentiate the angle. It becomes 2x. So what I'm going to do, I'm going to say, okay, 1 over, hold the angle, my angle is x squared. Now differentiate the angle, that gives me 2x. And I'm done with this. And then from there, what is it that I can do? I have my ln x squared, which I hold, and then I am here now. Okay, so when I try to simplify this, I know that the angle there it is. I bring down this, hold the angle, and now differentiate the angle. So how are we going to rewrite this? That should be the question. How are we going to rewrite that? That's my question. How are we going to rewrite that? Now, when I'm here, I want you to see something. When I differentiated this, I brought down the 2, hold the angle, and differentiate the angle. So meaning, I cannot multiply this with this, because this, I have differentiated the angle here. So I can't say, okay, here is an angle of x, therefore I'm going to say 2 times 1 over x, giving you 2 over x. No. No, you can't do that. You bring down the 2, you hold the angle, and then you differentiate the angle. So this cannot be simplified any further. It stays as 2 ln x times 1 over x. It stays exactly the same. Plus, now let's come here. We hold on len of x squared, there it is, len squared x, multiplied. What we did here, we wanted to differentiate what? We wanted to differentiate this. So we leave this, and then we are differentiating that. So this is 1 over x squared, hold the angle, and now differentiate the angle. So what will this become now? Are we going to rewrite it exactly the same way as it is written, or are we now going to do some modifications? That is my question for that one. What are we going to do then? I know that there's nothing I can do with this. I'm going to leave this as len squared x. Or you can write it this way or this way, the choice is yours. I hold the angle and I differentiate the angle. There's nothing I can do there. I can rewrite this still as 1 over x squared times 2x. There's nothing I can do also with this. I can't say 1 times 2, that's 2x over x squared. No, because when you do that, you will be forced to say x cancels x. You can't do that. So please be very careful with the product rule here. It might give you some serious problems. So this is just your final answer. There's nothing you can do with that. And then let's go to the last one. In 4.5, so what I'm going to do is to come here. Are we in 4? No, sorry, let's go to 4.4. Sorry, it's a little bit long, so I'm going to try and erase this. So in 4.4, they say differentiate with respect to x. Y equal 1 over cosec 3x minus 1 over cot x plus root 2 all over e minus x minus 6 exponent of 2x plus 2 pi over p. Now we want to differentiate that. It's quite a lot that is given there, but we are going to try by all means to find the correct way of doing that. Now, let me just also erase this so that our attention may be on that one. We want to differentiate this. And the question is, how do we differentiate this? Just by looking at the first one. I know that cosec, it's 1 over sine. So I can say, okay, rewriting this, y equals 1 over sine 3x. Cosec, I have my 1, there it is. Cosec is 1 over sine. That's cosec. Okay, because I know that in here I have sine and cosec. I have cos and sec. So I know that minus 1 over, I know that cot, I know that in here I have tan and cot. So cot would be 1 over 10. So this is 1 over 10x. Let me do this. Okay, plus I can rewrite this as root 2 e exponent x. If I want to take this, writing this exponent as a positive, this is exactly what I should have. When it goes on the numerator, the exponent becomes positive. Okay, I will leave that 6 to x plus. I will leave this 2 pi over p. That's fine. And what I will do from here, I will simplify this. Now look what I will have. I will change division. You have your 1. Change division line to multiplication. You'll take the reciprocal, and this becomes sine 3x. So you're having y equals sine 3x minus the same 10x plus root 2ex minus 6 2x plus 2 pi over p. Now that we are fine, we have been able to rewrite our thing in the right way. Now I can begin to differentiate. I know that the derivative of sine, let me show you something. You know that the derivative of sine x, the derivative of sine is cos x, because you will say the derivative of sine is cos, you will hold the angle, which is x, differentiate x, you get 1. 1 times cos x is still cos x. Are we fine? Very good. So what I'm going to do, it's the same here. I'm going to say y prime equals the derivative of sine is cos, and I'm going to hold on the angle, which is 3x. Differentiate the angle, the derivative of 3x is 3. Minus, I know that the derivative of 10 is a sec squared. X, hold on the angle, which is x, differentiate the angle, you get 1. Okay, plus, I will factor out root 2. What is the derivative of e to exponent x? That's e to exponent x. Minus, now you remember this one, 6 2x. This comes from the derivative of y equals ax. You remember that the derivative of ax is, I think it's ax ln a. Yes, I think so. Because you will say, okay, the derivative of ln of a exponent x, that would be your a exponent x, the ln of a, because the derivative of this is 1. 1 times a is a. I think something like this should be provided to you in your answer, in your formula sheet. Let me just check. Let me check if this is provided. I don't see. Yes, I think it's provided. Yes, Kax equals Kax ln a. Right. Now, using this, let's try to work on this. So, meaning we will have 6. I've been forgotten because I deal with a lot of things at one and the same time. So, I'm very sorry for that. And then in 4.5, differentiate, they say if f at x equals, we are given that f at x equals 3x3 plus 9x squared plus 3x plus 7. This is f at x. Determine with the aid of differentiation the x coordinate of the point of inflection. If this is the function, determine with the aid of differentiation the x coordinate of the point of inflection. I know that I will differentiate this for the first time. And for the point of inflection, you will differentiate for the second time. And you will say f double prime equals to 0, 18x plus 18 equals to 0, and your x will be your minus 1. And to find the corresponding value, you will say f at 1 equals 3 into 1, 3 plus 9 into 1 squared plus 3 into 1 plus 7. This should be 3 plus 9 plus 3 plus 7. And 3 plus 9, 12. 12 plus 3, that should give you 15. And then 15 plus 2, that should give you 22. So this would be minus 1 and 22 as a point of inflection. As a point of inflection, if that is what is provided to us. The value is minus 1. I'm sorry. The value that we are substituting there is minus 1. So this should be minus 3. And this should be a positive. This should be a negative. And the value should be minus 3, it's minus 6 plus 7 is 1, 1 plus 9 is 10. So minus 1 and 10. I'm very sorry, the value is negative then. And then when we are done with this, I think I will see you in the next tutorial.